The lifespan QoS policy. The lifespan QoS policy is a way to remove data automatically from a queue based on time. Basically, you're setting expiration time for data. And expired data is automatically removed from the data writer and data reader caches or queues. From a data writer cache, even if the data hasn't been acknowledged by all reliable data readers, expired data will be removed. In the data reader queue, if the data is in the data reader queue has not been read by a data reader, has not been taken by a data reader, if it expires due to lifespan, it will be removed. So lifespan is calculated based on the time when data was written for data that's in the data writer queue, or when from the time that the data is received for data that's in the data reader queue. So the lifespan QoS policy is configured with a duration, and this duration basically sets the expiration time for a data sample. And expired data will be removed automatically. So when you remove it from the data writer queue, it can't be resent anymore. So it can't be resent for durability QoS. It can't be resent to support the reliability QoS. When it's removed from the data reader queue, you can no longer read the data again or take the data again. Now, you only configure the lifespan for a data writer. Okay, so the data writer determines the lifespan of its data that it's sent. The data reader discovers a lifespan set for a data writer, so when it receives data from a data writer, it will use a lifespan set by the data writer. Also, all samples sent by a data writer will use the same lifespan. You can't say that this data lasts longer than this other data for the same data writer. It is, however, changeable as you run DDS, so as the application is running, if you want to change the lifespan for a data writer, you can. However, note that it's not really something that you're going to be able to do per data sample unless you're sending a data samples with a long time in between, because it will take some time to propagate the changed value of the lifespan to all the data readers. When is data removed when their lifespan expires? So we have three cases here. One is the data writer that actually publishes the data. Don't forget that lifespan QoS is only set by the data writer. And then we have two different types of subscribers, or different ways that applications can receive their data. One is a user application, and the other one is perhaps an RTI service, and this example, a persistent service that can also receive the data. So as you send data, of course, it'll be propagated and sent to the data readers, in this case, both the user application and the persistent service. On the sender side, on the data writer side, the data will be removed when the host time, the local clock, is greater than when the timestamp taken when the data was sent, called the publication timestamp, plus the duration of the lifespan. So when your clock exceeds this time, when the local clock exceeds this time, that data will be removed. Now for data readers, either the user application or persistent service, the time that's removed from the local host time, the local clock of the data reader, is greater than the reception timestamp plus the lifespan. Now the reception timestamp, again, is a timestamp that was taken with the local clock when the data is received. In terms of absolute time, the reception timestamp and the publication timestamp should be taken pretty close together, within microseconds or at least milliseconds within a very closed system. It may take a little bit longer if you're sending data over the internet, for example. But in terms of just absolute time, the publication timestamp and the reception timestamp are going to be pretty close when they were taken. But the clocks do not need to be synchronized. So clock synchronization is not needed, okay, between hosts, because the expiration actually is going to use the local clock for both the timestamp as well as determining when expiration has occurred. Now, lifespan for command and event data. Is it useful? Well, sort of kind of depends on your system requirements. Some systems, they want to make sure that old commands are not consumed or sent or processed. So now what does it mean to be old? Now, again, that's your requirement. Maybe commands are okay. If people get a command sometime after it was actually sent, that's okay for your system. But for other applications, it's critical that they don't execute data that gets in too late or commands that are coming in too late. Lifespan is also very useful for state and status data. Okay, so in a state or status data, maybe you have a queue of old data. Okay, a queue of data that's sent. But what you want to do is automatically remove old data from those queues. So if you're storing some history queue of old data, then you can use actually lifespan to make sure that you're only keeping some of the data. For example, if you have a history depth of 100 and the default lifespan is infinite, then you're going to keep basically the last 100 log messages. Okay. So the last 100 log messages, well, those log messages could have been published yesterday for all you know. You could also use history keep all and a lifespan duration of, let's say, 5 minutes to keep the last 5 minutes of log messages. So by kind of changing history, changing lifespan, you can determine what messages you actually want to keep for a topic.